Good afternoon. You're welcome to my channel once again. We have discussed about complex number before, looking at the rectangular form. Today we want to look at the polar form, and then we have a question that we should prove the DeMoivre's theory, which is z to the power of n equal r to the power of n cos n theta plus I sine n theta with illustration. So right now we will going to discuss about the polar form of complex number. So what I'm going to do is I will be drawing a circle which will be having just two coordinates, the y and the x. Right, let's say from the center to any parts touching the circumference, that line is called the radius. So I'm going to be giving it r. Okay, now we're going to be resolving r to the y-axis and to the x-axis. So I will, the angle is to the horizontal theta. So at this point, I'm going to call it x comma y. Now let's resolve r. Let's say r is a vector quantity. Okay, let's resolve it to the y and to the x coordinate. So what we're having right now is we're having a right angle triangle. So we're having r here, then we're having theta, then we're having x, and this y. Using Pythagoras and Socrates, this becomes the opposite. Where the angle is facing is called the opposite. So automatically this becomes the adjacent. This becomes the hypotenuse. So resolving r vector r to the y and to the x will be sine theta equal opposite over hypotenuse. So sine theta equal, the opposite is y, the hypotenuse is r. So right now we have our first identity, cross multiply. It means y equal r sine theta. That will be very, very important for us in proving the DeMoivre's theory. Okay, the other one will be cos theta equals adjacent over hypotenuse. So we're having cos theta equal, the adjacent is x, the hypotenuse is r. So cross multiplying, we're going to be having x equal r cos theta. So we'll be needing these two formula to actually prove. So now we have x equal r sine theta, and then we have y equals r sine theta. Sorry, x equal r cos theta and y equals r sine theta. Now back to this, we can say from Pythagoras theory that r square equal x square plus y square. That is hypotenuse square equal opposite square plus adjacent square. If I take the square root of both sides, we will now be having r equals square root of x square plus y square. This also is important. And r is called the modulus or the amplitude or the absolute value of z and theta. All right, and is the argument or the phase. Okay, so from our previous class, we said that z equal x plus I y, where I is the imaginary, it is the complex number, what we discussed about. I is the imaginary value. So we're going to be having z equal, instead of x, I'll be writing r cos theta plus I. Instead of y, I'll be writing r sin theta. So therefore we can say z equal r open brackets cos theta plus I sin theta. So now we have this formula. If you don't understand anything, you can just return back to, like, you can look back and then look into what I just discussed. All right, now let's go deeper. Given that z1 equal r1 cos theta 1 plus I sin theta 1, and z2 equal r2 cos theta 2 plus I sin theta 2. Given this, let's find the product of z1 times z2, and let's see what our value will look like. So z1 times z2 will be r1 cos theta 1 plus I sin theta 1 multiplied by r2 cos theta 2 plus I sin theta 2. And let's simplify this. I'm going to be taking out r1 and r2, so I'll be having r1 r2 cos theta 1 plus I sin theta 1 cos theta 2 plus I sin theta 2. Right, for my elementary maths, we know that a plus b times a plus b equal a times a square, plus a times b, ab, plus b times a, ab, plus b times b, b squared. Alright, we're going to be using this same illustration to actually expand this. We'll be opening brackets. Okay, let's proceed. r1 r2 cos theta 1 times cos theta 2 is cos theta 1 cos theta 2. Cos theta 1 times I sin theta 1 sin theta 2 will be plus I cos theta 1 sin theta 2. I sin theta 1 times cos theta 2 will be plus I cos theta 2 sin theta 1. Remember that the multiplication is commutative. That's a times b, the same thing as b times a. Alright, so I know some of you might be asking, why am I writing cos first? You can actually decide which one to write first. So I times I square sin theta 1 sin theta 2. Alright, so let's simplify this. r1 r2 cos theta 1 cos theta 2. Now I want you to take a look at this. Remember in our previous class that we said the square root of -1 is I. Taking the square of both sides, square root of -1 square and I square. Square we cancel square roots, so I square equal -1. That's from our previous class. So it means that everything here will be minus sine theta 1, sine theta 2. Alright, because I square is -1. So I'll be having minus sine theta 1, sine theta 2 plus this complex number. I'm going to just factorize I out, and I'll be having cos theta 1 sine theta 2 plus cos theta 2 sine theta 1. I hope no one is confused at this point. All right, from our trigonometry rules, we'll recall that cos A plus or minus B equal, all right, let me do that for plus. It means cos A cos B minus sine A sine B, and cos A minus B will be cos A cos B plus sine A sine B. That's one of the rules. We also have that of sine sine A plus B equal sine A cos B plus sine B cos A, and sine A minus B will be sine A cos B minus sine B cos A. Alright, using this already existing rule, we can actually simplify this. Now we're seeing cos theta 1 cos theta 2 minus sine theta 1 sine theta 2. Which of these is applicable to this? I believe it is this, right? So it means that everything here can be simplified as cos theta 1 plus theta 2. Alright, let's look at this. We're having cos theta 1 sine theta 2 plus cos theta 2 sine theta 1. Which of these among these two is applicable to this? It's this. Just imagine this: sine theta 2 as sine A, cos theta 1 as cos B, plus. Now you look at cos theta 1 becomes cos theta 2 here, cos theta 2 becomes theta 1 here. It's the same thing. A becomes B, B becomes A. So it means that everything here is sine theta 1 plus theta 2. So having said this, it means that Z1 times Z2 equal to R1 R2 cos theta 1 plus theta 2 plus I sine theta 1 plus theta 2. This is the general formula or the DeMoivre's theorem. But actually we are asked to prove that z to the power of n equal r to the power of n cos n theta plus I sin n theta. Okay, so let's prove that. Let's say z1 equals z2, and if they are equal, let me give it a general term z. It means r1 will be equal r2, let's say r, and then theta 1 equal theta 2, let's say theta. Okay, having assumed this, it means that z1 is now z times z equal r times r cos theta plus theta plus I sin theta plus theta. If this permits me to write outside this margin, so z times z will be z. Okay, now let me just write it behind. Z times z will be z square equal r times r, r square. What do we have again? Theta. Okay, so we're having cos 2 theta plus I sin 2 theta. Right, let's say we have multiples of 3, multiple of 4. It means if it's to the power of 3, we're having z to the power of 3, r to the power of 3, cos, look at this 2, this 2, this 2, so this will be what, 3 theta plus I sin 3 theta. So it means that if this power changes, it means this will change, this will change, this will change. So we can say the general form will be z to the power of n equal r to the power of n cos n theta plus I sin n theta. So this actually proves what we want to prove. All right.